Variance of a continuous random variable. In the previous lecture, we saw how to find the variance of a discrete random variable. How did we find it? If x is a discrete random variable, variance of x is equal to sigma I equal to 1 to n. And what did we sum over? Probability of xi into xi minus mu the whole square. What is mu? Mu is the expectation of that random variable. That is summation I equal to 1 to n, right? P probability of xi into xi. This is mu. So using this formula, we found mu, and that mu has to be used here in order to find the variance. This is what we talked about discrete random variables. Coming to continuous random variables, we don't have exact values like this in xi. So we can't use the same way. We can't sum over all the values of xi because continuous random variable does not take discrete values. So what do we do here? We integrate. How do you integrate? You take variance of x is equal to integral. I'll write here r in order to denote the range over which you are integrating. So it will differ on your particular problem. X minus mu the whole square into p of x is probability of x, p of x dx. This is how you integrate. So if, let us say, if we expand, this is of the form a minus b the whole square. So this will become integral over the range. What will this be expanded to? X square minus 2 times x into mu, right? Okay. X square minus 2 times x into mu plus mu square, right, into p of x dx. And now if I take this p of x inside, this will become integral over the range. I'll separate all these terms. So the first term will become x square into p of x dx, right? The second term, what will it become? It will become over the range of r. I'll take 2 outside, mu into x into p of x dx, right? Plus integral over the range r. This last term will become mu square into p of x dx. How can I further simplify this? I'll erase this from over here and we'll write it on the top. Okay, so I'm writing the remaining steps on the top. First term, x square into p of x dx. So can you do anything with this term? No, it will stay as it is. That is over the range r, x square into p of x dx. This term will stay as it is. What about the second term? 2 times integral over r, mu into x into p of x dx. If I take 2 mu outside, it will become minus 2 times mu into integral over the range r, x into p of x dx. Is this term familiar to you? X into p of x dx. What is that? That is the expected value of x. That is mu. What is a mu? Mu is a expected value, which is x into p of x dx, integral of x into p of x dx. This is a mu, which is expected value. So here the term that we got, this is mu only. So you can substitute the term mu here. So this will become mu square, right? And next, the last term, what is it? Integral of mu square into p of x dx. If I take mu square outside, it will become over the range r, p of x dx. What is integral of p of x dx? If it is a probability and you integrate over the whole range, probability should be 1. That is, see, over different ranges, it will have different probabilities. But if you add up all those, if you integrate, it should be 100% possible, which means probability should be 1. So this term will totally come down to 1. So I can remove this. So this will become mu square. So if I simplify this, let me erase all these. And so this will become variance of x, where x is a continuous random variable, is equal to, I'm just copying these things here, over the range r, x square into p of x dx minus 2 mu square plus mu square. That will become minus mu square. Okay. So minus mu square. So this is your formula for variance of a continuous random variable x. And here let me mention mu, where mu is equal to integral of x into p of x dx, because mu is the expectation. This mu is the expectation of random variable x, and this term is the variance. Over the range are integral of x square p of x dx minus mu square.